All right, good morning, everyone. Today is our last official content unit, or content for the unit. So we are going to look at the chi-square test for independence, sometimes also called the chi-square test for association. And this is actually going to work pretty similar to the test for homogeneity in terms of calculating our test statistic as well as how we get the p-value. The only thing that's really going to be different about this is what exactly we are testing for in terms of our hypotheses. So let's go ahead and take a look at this example here. So note that the chi-square test for independence is a performed test to see if one category is independent of another category. So this was sorry, my pen's not working. Okay, so this was the formula that we used on Tuesday and Wednesday of this week. And yesterday we used our calculator to calculate the test statistic. So we are again going to do that today. And like I said, the only thing that's going to be really different is just the hypotheses. So looking at this example, we have a group of researchers wondered whether vegetarians favored different seasons than non-vegetarians. The researchers took a random sample of people and they surveyed them about their favorite season and whether or not they were vegetarian. So here are the responses and partial results of the chi-square test. And then they want to carry out the chi-square test of independence, assume that the conditions have been met. So taking a look at this, note that they're not trying to see if they have a similarity between their favorite seasons. They want to know if they favored different seasons, not similar. And so looking at this, you might think, well, okay, so if we're trying to test difference, isn't that going to be homogeneity, since that's our alternate hypothesis? And you could be right. However, one thing that we are looking at here is to see if one category is independent of another category. So those categories that we're looking at here is vegetarian versus non-vegetarian. So we know, well, because the problem does say carry out the test for independence, but even if it didn't say that, we're looking to see if one category is different from another. So this is to see, are vegetarians different, morally independent than non-vegetarians in terms of their favorite seasons. So that's what we're looking for independence. Again, in our AP exam, in the multiple choice, it's really not going to matter if it's independence or homogeneity unless they ask you about your hypotheses. Really, the only thing that they care about is, are you able to calculate the test statistic? And we do that the same way for both homogeneity and independence. So honestly, it's not going to matter unless they ask about the hypotheses, which they rarely do. So don't get too caught up in telling the difference between homogeneity and independence. Just note that independence, we are trying to see if categories are independent from each other. And then homogeneity, we're trying to see if there are similarities between groups of people or grades, like we did in our example practice set yesterday, whatever that may be. So let's go ahead and just create our hypotheses for this problem. So for the null hypothesis, we are always going to say that there's an independent relationship. So, or excuse me, just independence here. Wow. Independent. Morally, if things are independent from each other, we know from the definition of independence and probability that the probability of one event occurring doesn't affect the probability of the other occurring. So really here we're saying that there's no relationship going on between them, or really no association. So there's they're independent of each other, they're not related, there's no association going on for the null. For the alternates, they're trying to see if they are not independent, if there is some sort of relationship going on between vegetarian and non-vegetarians. So here, it seems a little counterintuitive that our null would be independence, but that is the case here. So to test these hypotheses, we need to, normally we would test our conditions, but here they say assume that the conditions have been met, so we don't need to do that step. But I encourage you to pause the video and to actually test the conditions yourself so that you get in the habit of doing so. But again, since it says assume the conditions have been met, we don't need to do that step here. So we can go ahead and jump right into testing our, or calculating our test statistic. One thing that I do want to note, in this problem specifically, they tell us that the expected counts for independence appear below the observed counts. So this is like the practice set yesterday. If you tuned in on the Zoom call, we indicated that we do not want to include the expected values in our matrix in the calculator. So I'm just going to cross those out because, as we noted before, we really only care about the observed values, and that is these values here that I'm boxing. Those are the observed values. Additionally, I do not want to include the totals, so I'm going to cross that column out as well so that I note to myself I'm not including the expected values, I'm not including the totals, I'm only including the observed values. So let's go ahead and jump to our calculator to calculate our test statistic and our p-value. So let's go to our calculator. And excuse me, again from the steps yesterday, in order to calculate this, we need to enter the values into a matrix, so a table of sorts. So seconds, x to the negative first, and then at the top I need to scroll over to edit, and I need to go to matrix A, and it asks me how many rows do I have. Well, I'm going to go back to my problem and I'm going to see, okay, how many rows did I box? Not how many rows are in the table, because again, I'm excluding those expected values. The calculator is going to do the work for us. So I just want to include 1, 2, 3, 4. Ooh, I did make a mistake here. I boxed this total at the bottom. I do not want that either. So I'm just going to include 1, 2, 3, 4 rows and 2 columns. So row 4, enter, 2 columns, enter, and then I'm only putting in those observed values. So 6, 78, 9, 55, 15, 133, 6, and 58. So those are my observed values. And so now once I have this in the table, I'm just going to press second quit so I can go back to the home screen. And then to actually calculate the test statistic, I go to Stat, Tests, scroll over to Tests, and then the chi-square test looks like x squared. And again, the observed values, the ones that I just put into matrix A, that's listed here, A, and then it's going to auto-calculate the expected values. So I can go ahead and just press calculate, and here it'll give me my test statistic, the p-value, and my degrees of freedom. So I can write chi-squared is just equal to 1.966. My p-value that they already gave me was 0.579, and my degrees of freedom was 3. So again, they calculated that based on the rows minus 1. So they did 4 minus 1 times 2 minus 1 to give us 3. One thing that I do want to note that I saw a few people making mistakes on was with their p-value yesterday, especially in the exit ticket. Please make sure that you are looking at the whole p-value. If you, for some reason, get 1.2 as your p-value, that should be a red flag. Your p-value is a probability. We should never have a probability greater than 1. So if you do get a p-value that is 1.2, be sure to look across the whole row with the p-value because it probably is written in scientific notation. So I got a few questions on that yesterday. I saw a few people making that error on their exit ticket. You need to make sure you have the whole p-value. So if it is greater than 1, it is going to be in scientific notation. So that should be a red flag for you. Here, this is 0.5, so we don't have that issue. But if it were to say 5.7, I better make sure that I'm looking at the whole thing and making sure I have the correct p-value. So because we are not given an alpha in this problem, we're going to say alpha is 0.05. And so our p-value is definitely greater than alpha. So we are going to fail to reject our null, meaning there is no relationship or there is independence between vegetarians and non-vegetarians. So that is our final conclusion. All right, so please jump on to the Zoom call at 7:20 if you have any questions. We will be doing a problem like this together, so that might be a little bit more beneficial for you if you are unsure with using your calculator. We will be doing this as a we do together, so please join us on the Zoom call at 9:20. Thank you to those who have been consistent in joining on that call to get your questions answered. And then finally, please just make sure you're submitting your classwork in the exit ticket by 5 o'clock every day on Google Classroom. All right, have a great rest of your day, everyone.